Hello, in this video I'm going to compare two different methods for showing the steps of long division. First we'll look at the British method. So the question that we're going to be looking at to start with is 96 divided by 8. In the British system, I'm going to take the divisor 8 and write it out front. And I'm going to be dividing that into 96, which is my dividend. And the first thing I want to look at is how many times does 8 go into 9? It goes in once. I'll write that 8 underneath here, 1 times 8. And then I do subtraction. The result is 1. Carry down this 6. Now I'm left with 8 into 16, goes twice. 16. Result is 0. So when students are first learning this algorithm or this process, the carry down sometimes causes confusion. Also, there's some confusion related to getting everything lined up correctly and the subtraction. Sometimes errors occur there when things aren't lined up very neatly. Okay, so looking at the way that the French would organize this same division problem, starting with how it is written in longhand or just written out in the question, 96 divided by 8. So the organization of those values is the same. So you start with 96 and then you write 8 is what you're going to be dividing out of it. So it's called actually a system of partition or of separation because the way that it is organized is considering you've got a total of 96 and you are separating out, you are pushing off to the side how many groups of 8. So you can imagine that little L shape is a little separator bar. Kind of like a hook pulling off to the side. Okay, so now I extend this vertical of that hook. So it makes a line like that. And then I start a similar process. I think, okay, what's a number that's less than 96 that 8 can be multiplied by and create? So I'm looking for multiples of 8. I could do an easy one. I'm going to use reference in this case. I'm going to do 8 times 10. Because 8 times 10 gives me 80. That's a nice round number. It's easy to subtract. When I subtract 96 minus 80, that gives me 16. Now I think, okay, what's a multiple of 8 that makes 16? Well, that is 1 times 2. 8 times 2 is 16. And the remainder is 0. So with this first example, what I want to point out is that in terms of the efficiency of how much paper it's going to take or how much space it's going to take to state the answer, it's pretty comparable. So the result of separating out groups of 8 out of 96 is 10 plus 2 or 12. So that's my quotient, 12. I always draw a double line there underneath to indicate that below that is your total. Okay, let's look at another example. We're going to do 1701 divided by 9. Okay, so this is example 1. This is example 2. So in the British method, I'm going to reverse the order of the numbers. I'm going to put the 9 first. I have to leave a little bit of room for the quotient. And 1701. Like that. So already I don't find that as intuitive. Why does it switch position? Well, because that's the way the British decided it should be. Okay, so I'm looking for a multiple of 9 that goes into 1. No, it doesn't. Goes into 17. Yep, I can get a 9 out of 17. And that leaves 8. And then drop down this 0. I'm just using color to illustrate the different steps there. And I think, okay, what's a multiple of 9 that is close to 80? Well, I've got 72. That's 8 times 9. I subtract that from the 80. That leaves me with another 8. And then I'm going to drop down this 1. That makes 81. How many 9s in 81? Well, it goes in perfectly 9 times, remainder of 0. Okay. So part of, as I said before, what can go wrong when using the British algorithm is organization. If a student has difficulty with writing neatly in columns and getting everything lined up correctly, it can wreak all kinds of havoc. Okay, let's do that same problem of 1701 divided by 9 using the French algorithm. So start with 1701, separating out groups of 9. And I don't need to leave extra space at the top of that because the French system or the French process, you write the question here and then the work builds below that. There is no adding things on the top like in this British system. Okay, so again, I'm going to look for what is a number that is a nice round number that I can multiply by 9 and get rid of some of these 1701 that I've got to partition up or divide up. So let's say 100, 9 times 100. Well, that's 900, so I'm going to take those away. They've been accounted for. The result of 1700 minus 900, well, it's going to be 801. Okay, now I need a multiple of 9 again. Well, if I go 9 times 8 is 72. So if I do 9 times 80, that's 720. Again, subtract. Now that gives me 81 left over. 81, 9 goes into that 9 times. And that's 0. So the result here is 189. Same answer, same result. The difference being that the subtractions that I'm doing are using perhaps easier numbers to think of. But I'm going to show you one more thing that I like about the French method, excuse me. I'm not limited to using the values of 1, 8, and 9. If that wasn't the first thing that popped into my mind, that's fine. I can use any multiples that I think of. So for students who maybe have a better handle on multiples of 5 or 2, they can rely on that. So let's look at, we're going to do that one again using different multiples this time. So I'm still going to use that 100 because that was a good way to get rid of a lot of units all at once. So 9 times 100 is 900, and that leaves me with 801. 801 is awfully close to 810. 810 is 9 times 9t. 9 times 9 is 81 times 10. This time when I do that subtraction, I'm left with minus 1. Minus 9. How many groups of 9 in minus 9? Well, there's minus 1 of them. I did a jump in my mind there. So what happens when you take 190 and you subtract 1? It still gives you 189. So second example, that's a way of verifying that you got the right answers by using a different multiple. Okay, we're going to try one more combination just to show the flexibility of this technique. So 1701 divided by 9. And this time I'm going to go actually for 200. Because I know that 2 times 9 is 18. So 200 times 9 would be 1800. Subtract. The result of that is minus 99. How many 9s in minus 99? Negative 11. So my remainder is 0. That's good. And when I look at this total here, 200 minus 11, guess what? It's still 189. So 3 different steps, 3 different ways of breaking it down, of dividing out groups of 9, that all verify that indeed that is the answer. And that's why I prefer the French long division algorithm over the British algorithm.